I recently ran a poll to see whether or not you guys wanted to see deeper dives into subjects or if you would prefer just one-off videos, and you said that you'd prefer some deeper dives. So I figured we would start off with particles because particles are used in a lot of different things inside Houdini, including other simulation types, so it's a good place to start. So I'm going to work inside of Solaris, but you can work in the geo context. They are going to basically work exactly the same once we drop down a SOP create here. In Solaris, this just gives us access to the geo context. Now, you guys would drop down a geo container if you would working in the geometry context, but for us, we're just going to drop down our SOP create, and now we have access to the geo context. So first of all, we need to talk about what a particle is. And at its base level, a particle is quite literally just a point that is in 3D space. So if I drop down an add node and I add a point here, we have a point at our origin. And this is, like I said, at its base level, a particle. We can render this as a sphere. Particles, we can all render as spheres, or we can render it as objects and just copy those objects at render time to our particles. There's lots of different things we can do. And just remember that at the base level, it's just a simple point in 3D space. So if we wanted to, we could do things, at the geo context here, at the geo level, and, move it around and do all sorts of things. But just in general, we're going to use a popnet. That is the typical workflow for particles. So on our popnet here, we can take a look. We have what's called a popnet, but it's actually just a DOP network. So we have access to all of the DOP nodes inside of here. But on our popnet, we can take a look at our simulation here. There's a couple of things that we need to look at. So first of all, we have this reset simulation button. If I go ahead and press play here, we see we have this blue bar coming across our timeline. That's going to be showing what is cached and what is not. If we make a change inside of our popnet here that's going to affect our simulation, this blue bar is going to turn a different color. It'll turn orange. And that just shows that there is a change inside of the popnet that is not being reflected in our viewport. So we would have to reset our simulation in order to do that. Now, you can either jump back to the beginning, and that will sometimes reset your simulation, or sometimes you will have to click this reset simulation button, and you can see that our cache has disappeared. Now, if I move forward here after I have simulated some, so we have this blue bar going past where we're at currently. If I click reset, it's going to reset and then simulate up to the frame that we have. Now we don't have anything in our scene yet, so that's not really going to do anything, but I just wanted to show that's how that works. So if I look here, we have a substep option. So this is going to just be set to 1 by default, and I'm going to leave it on 1 for the most part. You want to keep this as low as you possibly can, because as we increase this, it's going to increase our simulation time. So what this means is at a value of 1, it's going to do 1 calculation every frame. If we set this to 2, it's going to calculate twice per frame. So it'll calculate at frame 1, and then frame 1.5, and then frame 2, and then 2.5, and so on and so forth. So we can increase this for certain situations. One that comes to mind is going to be collision behavior. You may have particles that are moving quickly and they pass through an object, and in that case, you would want to increase your substeps in order to try to calculate or try to capture that collision so that you're not just passing through your collision object. Now we also have our start frame, so we can change which frame we want to start simulating on. If I set this to like 10 and I press play, you can see that the simulation doesn't actually start happening until frame 10. I'm going to reset that. And then we also have this time scale or scale time option. So if I set this to a value of 2, the simulation is going to simulate faster, not as in like your computer is going to simulate faster, but the simulation is going to take place at double the speed. So if I have a particle that's simply just moving up 1 unit per frame, if I set this to a value of 2, it's going to move up 2 units per frame instead of 1. If I set it to 0.5, it'll go up half a unit each frame instead of 1. So you can use this to kind of speed up simulations or do some sort of like bullet time type effects. Not typically how you would do that, but you can kind of do that type of thing with this as well. So we have the cache options next. So as we talked about, as we start to simulate across here, we have this blue bar that starts to appear. That's going to be directly linked to this cache memory. It's by default set to 5,000. So as we start to simulate, we may notice that we run out of RAM and it starts to not keep our whole timeline in our memory. So the way that we know that is the start of this blue bar, it's at frame 1 right now, but if we start to run out of memory, that's going to purge the start of our simulation there, and you'll see this blue bar start to creep towards the right here, towards the frame that we're on. Now, if you don't want that to happen, you will need to increase the cache memory limit, so you can keep your entire frame range in your RAM so that you can play it back if you would like to do that. Now, that can quickly add up, and depending on what you're doing, that's not always feasible, especially depending on the amount of resources that you have. So just keep that in mind. We also have this save checkpoints. So this allows us to make a checkpoint of our simulation. So basically, if we were to simulate up to, frame 50 or whatever, then it would make a checkpoint, and we would, if our computer, crashed or whatever, then we would be able to load that checkpoint. We wouldn't have to just re-simulate up to that point. We could start a simulation at frame 50 and it would continue on like normal. So that can be useful for, certain things where maybe you're worried you're going to have a power outage or something. I don't know. You can, enable this checkpoints and save yourself some time. So if we want to actually add some particles or start to spawn some particles, we need to give this PopNet a input. So I'm going to drop down a grid. I'm also going to drop down a sphere. I'm going to wire our grid into the first input, and I'm just going to leave our sphere over here to the side for now. If I go back to our first frame here, you can see that we have our particles already being spawned onto our geometry. So let's dive inside our PopNet, and we can see where that's coming from is this pop source. So if I select that, first and foremost, we have this guide option. This is going to show a guide of what our source is. So if I uncheck that, you can see that our guides go away. You can re-enable that if you would like. Sometimes it can get in the way, so I would just recommend keeping in mind that this is where you enable and disable that. Now we also have our emission type and geometry source. So for this, we're using the first context geometry. If we dive back up, you can see that we have our grid wired into the first context here, or our first input. So we also have 2, 3, and 4, and those are going to directly correspond to second, third, and fourth context geometry options. Now we also have a DOP object that we could use if we wanted to, or we can use parameter values, which if I select this option here, we can just navigate to our sphere, and I can select that, and you can see that we're now using that sphere as our emission object. I'm going to go ahead and set that back to use first context geometry. And let's take a look at emission type here. So we have a few different options here. By default, it's going to be scatter onto surfaces, and that's just going to scatter our points onto the surface of our geometry. We also have all points, which if I select that, it kind of looks like things just disappeared. If I uncheck this guide option, you can see that we're actually spawning on the actual points of our geometry. If I set this back to the use parameter values, you can see that we're spawning onto that sphere. If we wanted to set this to points, this is going to get rid of some of the points. So it's going to randomly spawn points or particles onto the points of our source. It's not going to emit from all of them necessarily, so just keep that in mind if you want to use these. They are very similar. We also have all geometry, which to be honest, I don't think I've ever used. I'm just going to add in another node here, which is going to be called gravity force. And with our gravity force, this just adds gravity to our scene, so we can wire that in there. And if I press play, you can see that we have just these grids that are being emitted basically. So we can kind of emit our objects if we would like. Like I said, I've never really used this. I just would do this later on if I wanted to emit the objects. It's a little bit cleaner to do that way, in my opinion. So not really sure why you would use that, but it's there if you need it, I guess. So let's go ahead and set this back to scatter onto surfaces, and let's re-enable our guides here. So it's important to note, like we talked about, that this is scattering onto the surface, so it's going to go kind of based upon where these polygons are. It's not necessarily at the points, but it will spawn them anywhere on the surface of your object. So we can affect where that happens by using either a source group or an emission attribute. Let's go ahead and set that up. So let's drop down a group, and we can wire this in. I can uncheck this space group and just keep by random chance. And if I look here, we have just a random distribution of our group onto our primitives, or primitive inside of our group. I can also drop down an attribute noise. And if I take a look at this, let's set this to be a float. And I'm going to just increase actually the resolution of our grid. Actually, before I do that, let's look at the group, because that's going to affect our distribution here. So if I look in here and I set this source group to our group 1, you can see how that affects our distribution of our points. You can see that we're only scattering within that source group. And I could invert that if we wanted to and get the opposite. But that would be one way of getting a finer control over which polygons are emitting your actual particles. I'm going to jump back up here, and let's come back in here to this attribute noise. And let's increase the rows and columns of our grid to 100 by 100, just to have a little bit nicer looking noise. And I'm going to check on this animation. I'm also going to increase the element size, and I'm going to increase the pulse duration to something like 10. And I'm also going to use the remap ramp, and I'm just going to kind of clamp this down a little bit. So you can see if I press play that we have our noise that's evolving here. So if I jump back into our PopNet after we change the name from CD, I'm going to call this emit, and let's come back to our PopNet. I'm going to disable our guides here and also get rid of that source group. We can come to this emission attribute and we can select our emit. And you can see that that's going to just add in our particles only where we have a value. If I preview this, see, only within these values. So anywhere that it is 0, it's not going to emit from. So we can use that. If I press play, you can see it's actually, well, it's going to be kind of hard to tell, I guess, with the gravity. But this is actually going to change where it's playing, or where it's spawning the particles on with our animation. So let's just disable that gravity for now. And you can see that we start to fill this up, and you can see that as we simulate across here, you can see that our animation is being played on our attribute noise there, so it's spawning them in different places. So that is a good way of controlling where your emission is happening as well. And you have, similar to like the scatter on surface node, you have some relax iterations. You have some different things that you can play around with in order to get some different looks with this. But we also need to talk about our birth and our birth rate. So if we take a look at this birth section here, we have some different things with this. So we have an impulse activation, we have a constant activation, and we have a constant birth rate. If I just reset this and I increase this constant birth rate to like 50,000, you can see that that's going to spawn a bunch more particles. So a lot more, a lot quicker. We can just change this. If we wanted to only emit on the first frame, you could do $FF is equal to 1. If I press play, you can see that it's only emitting on the first frame. Now you could set this to like, I don't know, 3 or something, and you could see that it's only going to emit on the third frame. Let's go ahead and delete this out and reset that. Let's actually set this back to 0. And let's take a look at impulse activation. So this is set to 1. So we could set this to like 5,000 again. And you can see that this is going to spawn particles with this impulse activation. So it's going to spawn, if you hover over, it says turns impulse emission on and off. Impulse emits the number of particles in the impulse birth rate below each time the operator cooks. A value of 0 means off. Any other value means on. So if I were to set this to 1, you can see that if I go forward the next frame, we get a second particle there. So if I go to the third frame, we get a third particle there. So it's spawning however much we have in this impulse count every single time that it cooks. So we could set this to like, 50,000, and we could set this to $FF is equal to 1, and then that's only going to happen again on the first frame. So those are common things that you're going to use this for. This $FF equals 1 or equals, some value or less than some value. You can get better control over this. So the difference between impulse and constant, if we take a look at the constant birth rate, this is the number of particles to emit every second. So the impulse activation the impulse count will spawn this number of particles every time it cooks. The constant birth rate is based upon your frame, like your frame rate, however many frames you have per second. We can also control the max number of sim points that we wanted. So if I wanted to set this to, let's delete this actually, delete channels, and we'll reset that back. I'm gonna set this back to 1. If I wanted to set this to like maybe 1,000, it's only going to spawn, or let's do 10,000 because it did that right away. You can see that it starts to spawn, and then once it reaches that value, it's going to stop spawning. We also have max points per frame, so it's only going to emit this number of points per frame. And probabilistic emission, this one I don't really mess with, but it changes the way that your emission happens. I'm going to let you read that tooltip on your own if you want. We also have this just born group. So when these are born, we could put like just born. So if we wanted to take a look at the attributes on our object, we have to come into our pop object and then click on this geometry here. So you can see that we have some things in here that's going to come by default. There's going to be some attributes that are added. If I scroll over here, we have this group JB, which is this just born group. So we have some particles that are being put into this group. When they're just born, they're going to be placed into that group, and that's going to be basically their birth frame. So once they're outside of their birth frame, they're going to be removed from this just born group. We also have this life expectancy. This is default set to 100, and that's going to be 100 seconds. If I look here, you can see how long the particle will live in seconds. So if we want them to just only survive for 1 second, then we would need to put 1 in here. Or if you wanted to, have them survive for 3 seconds, we can do that as well. And you can see as I press play there, you start to have the particles die off there and change because we have this max sim points set as well. We also have life variance. So this is going to be a variance in seconds as well. So if we set this to a value of 3 for our life expectancy with a variance of 1, the particles are going to live for anywhere from 2 to 4 seconds. So that's a good way to just add some variation to your simulation. I also want to take a look at this attributes. So by default, it's going to import all of our attributes or keep all of our attributes that we have on our input source. So if you remember, we have this emission or this emit that we have being added to our particles. It's being added to our particles because we have that on our actual grid. So they're going to inherit those values. And you can see we have age here as well. That goes back to this life expectancy. That's what it's called. We have some different hit things here. So these are going to be collisions and different things like that. Lots of things for the hit. That's, like I said, for collisions. Then we have IDs. And for that, we have basically it's similar to your point number, but your point number can change as the number of points are being spawned. Your ID will be basically like a constant point number. So keep that in mind because that's useful for some different things as well. Then we have this life. So if I come back to our life variance and I set that to 0, everything's going to have a value of 3. So this is the max age that your particle will reach. That's important because a lot of times you can use that in your actual shading. And the other things in here, we have velocity and we've got our groups. So different things with that, you'll have velocity. If we increase like our gravity here, we should get some velocity. You can see it's all the same because they're all getting the same amount of gravity applied to them, but they're grabbing that velocity. If we had velocity on our input object or our source object, then we can import that and use that to start off as well. So that is a quick overview of our, starting off with pop nets. We'll take a look more at, forces and gravity and different things in future videos, but I wanted to just cover how we can go about some emission. Also, I should point out, I guess, before we move on, the way that we can use multiple objects for emission. So I'm just gonna kind of move these off to the side. We can drop down and merge, and we can just merge these objects together. You can see now we have our sphere, and I can wire this into the first input. If I look in here, jump back to that first frame. If I were to set this to all points, you can see now we're emitting from both objects. So in other software, you might have multiple emitters. In this case, all we need to do is just add our objects together and we can create a multiple emitter type situation using that. So anyways, like I said, that is a quick introduction to particles and just kind of getting started. We're going to dive deeper into different things as we move forward throughout this deeper dive look into pop nets, but hopefully this has helped you out. I'm going to, like I said, be covering a bunch more things in this, so make sure to stay tuned for that. I'll make this project file available on Patreon as well as all, project files going forward. So if you want to grab them, you can grab them on there. I also have some other things on Patreon that are available for sale, as well as just a whole bunch of project files from the other videos that I've done in the past. So you can grab all those if you're interested and learn a bunch of different things about Houdini. But anyways, thank you guys for watching and have a good day.